Positive 1. Why is the answer positive 1 on number 1? Because 68 is an even number. And when you have a negative number on the inside of the parentheses, yeah, and it's even, if you were to expand it, you'd know that they all paired up, and a negative times a negative, when you pair them, becomes positive. So that is a positive 1. How about Paul, number 2?
Negative 1?
That is negative 1. And why is that negative 1?
There's
There's no
no parentheses.
parentheses, right? So the way to do this would be to go 1 to the 94th power, 1 times 1 times 1 times 1, 94 times. It's still 1, but you do have this negative out here in the front, so you need to put that negative in front of the 1 on your answer. So the answer is negative 1, once again. Eddie, what do you think about number 3?
Negative 15.
Negative.
Wait, hold on. My bad.
But okay, I like what you said. You said negative, right? And this is a negative number, and it's to an odd power. So when you do go a negative times a negative times a negative, I mean, you don't even have to think about it that way. It is an odd number, which means that there's going to be a negative left over, so your answer will be negative. So I like that you started with that your answer is negative. But now what is 2 times 2 times 2 times 2 times 2?
32.
32.
Yeah, I said 15 because I did 225, but that's not the right answer.
Okay, so all of this, guys, all of this is going to be on tomorrow's test.
Oh, it's 10.
All of this is going to be on tomorrow's test, and you're going to have to be able to do all this. So number 4, I made a small video on this yesterday, the shortcut of having when you have parentheses with a negative exponent on the outside, one option is to distribute, but then you'll have negative exponents on both of them, which means you're going to have to flip. Or the other option is, since it's negative, you could flip first, make it positive, and then distribute, right? You guys want me to do it both ways, or which way would you like me to do it? How would you do it? How would you do it? Okay, so how would you do it?
I will flip them.
You would flip them? Okay, so if you take the 2 and the 5 and flip it, you could change that negative 2 to a positive 2. So inside the parentheses, you could put 5 over 2, and that becomes a positive 2 on the outside. And then you could distribute the power of 2 to the 5 and the power of 2 to the 2. That's rule 3 and 4, right? When you have parentheses with an exponent on the outside, you could distribute it to each term. You have to multiply the powers. So you end up with 5 squared over 2 squared, which ends up being 25 over 4. And that's it. That's your answer, 25 over 4. That's doing the trick with the negative exponent where you flip the inside fraction. Now, you don't have to do that trick. You could actually distribute the negative 2 to each of the terms the way they are. So you would have ended up with 2 to the negative 2 over 5 to the negative 2. And then you'd have to take those negative exponents and flip them if you choose to do it this way. And then you'd have the 5 squared over the 2 squared. And then you'd get the same exact answer. 5 squared is 25. 2 squared is 4. So it all depends on how you want to do it. Copy those down, please. On number 5, a lot of students make mistakes. Now, students, you guys know that negative exponents need to be moved to the other side and become positive, right? So a very common mistake that students make is they see this negative 4 and they want to move it down. Wrong. Can't do that. You see, this is not a negative exponent. Remember, the only thing that moves from one side to the other is a negative exponent. And if I asked you what exponent does the negative 4 actually have, it's not a negative exponent. It's actually a positive 1 up there, right? So you're not going to move that down. It stays there. So what I like to do when I'm trying to simplify these rational expressions, I like to look at the coefficients and call that a regular numeric fraction. So if I did have the fraction negative 4 over 36, could I reduce that fraction? Yes. What could I reduce by? By 4, right? So if I reduce negative 4 over 36, what does it reduce down to? 9. Is it 9? Is it negative 9? Or is it 1 over 9? Or is it negative 1 over 9? Negative 1 over 9, right? So 4 over 36 reduces down to negative 1 over 9. if you say 9, that means you're writing the 9 on top, which is incorrect. It's going to be wrong. Now, if you're having, if you're struggling seeing where you have the 9 at, you could, if you wanted to, change the 36. You could change the 36. I'm going to scratch it out, and I'm going to put 4 times 9, right? And then the 4 right here will cancel with the 4 up here, so it cancels. And what do you have left? You have a negative sign on top, a -1, and the 9 left over on the bottom. Okay, now you don't have to do that. If you're good at reducing fractions, you're good, right? But if you're still struggling, maybe you want to change that 36 to a 4 times 9. And now we have x to the 5th and x to the 9th. And we know when you have the identical terms on top and bottom, the rule says cancel them out. So if you wanted to expand, you could write x times x times x times x 5 times, but that'd be a waste of time. Fact is, these 5 x's will completely cancel out with 5 of the 9 x's that are on the bottom, which means that there's going to be 4 left over. Everybody with me? So what do I actually have left over on top? Nothing besides a -1. But on the bottom, I do have that 9 and x to the 4th. And that's your answer. -1 over 9x to the 4th. Now on the multiple choice portion, it'll probably give you the answer with the negative in front of the fraction, like that. Okay? Probably give you the negative in front of the fraction as opposed to up there with the 1. Let's move on to number 6. One rule on number 6 is to distribute that outside exponent. Remember the rule where you have parentheses with an exponent on the outside? You have to distribute it to the inside and multiply by the exponents in there. So when I distribute the 3 onto the 3 and the 3 onto the r, I will get 3 to the 3rd, r to the 3rd. Now up on top we still have r to the 7th. Yay? So now that was one rule that we already applied. The other rule that we need to apply is what? And don't give me a number, but tell me what to do. What could I do? So yes, what we have left here, we can do the 3 to the 3rd. That's 3 times 3 times 3, which is 27. So I will get a 27 on the bottom. And then the r's, I do have 3 r's on the bottom that completely cancel out with 3 of the 7 up on top, which will leave me 4 left over up on top. So my final answer is r to the 4th over 27. Again, r to the 4th over 27 is your final answer for number 6. Let's move on to number 7. So on number 7, we do have negative exponents. We're going to apply rule 6. It doesn't even matter what number, as long as you know that negative exponents, you have to grab them and move them to the other side, right? I like to circle them and draw arrows. Now, even before that, guys, whenever you see parentheses, I recommend you to check and see if you have an exponent on the outside that you actually have to distribute in. And there is none, right? Even on this parenthesis right here, there's nothing on the outside, no exponent on the outside. Like there is no 3 right here that I need to multiply. Okay, so let me erase that. So you first check and see if there's anything to distribute. Power to a power, you multiply, but there isn't. So that means that the exponents are the parentheses are pointless. So what I would do is just rewrite it. So I'm going to rewrite it. M times n to the -2, p to the -3. Whenever I see parentheses, I check and see if there's an exponent on the outside, and if there isn't any, I just rewrite it without parentheses. So now, rule 6 that you guys said, which was when you have a negative exponent, you must take that term and move it to the other side of the fraction. Is this a fraction? No, but I could do this and make it look like a fraction, right? Yeah. Okay, so the n is going to go down, and the p to the -3 is also going to go down. So my final answer is going to have what left over up on top? M. That's it. But on the bottom, I have what? N to the 2 and p to the 3. Guys, if you're not understanding this, stop and ask me, because you're going to be on your own tomorrow. 100-point test. You're going to have to be able to do this on your own. Let's move on to questions 8 and 9 and 10. Let's copy these down, please. So on number 8, we need to remember the rule that says when you have parentheses with an exponent on the outside, you need to distribute to each and every exponent on the inside and a power to a power you multiply. Now, the smart thing to try to do is to look at the inside and see if you could simplify it first. For example, if I had 5 f's, I do have 5 f's up here. If I had an f down here or 7 f's down here, then I'd be able to cancel out a certain amount of f's, right? But there's nothing to cancel. There are no negatives to move. I can't reduce 2/3. So try to simplify the inside. But since you can't, let's move on to that distributive property rule of exponents, where you take that 3 and you put them on each and every term. And remember, when you have a power to a power, you multiply. So when I put the 3 on the 2, I end up with 2 to the 3rd. When I put the 3 on the 5, or on the f to the 5, I end up with f to the what? 15, because a power to a power, you multiply. Bless you, by the way. And then when I put it on the g, what do I end up with? G to the 3rd, because 1 times 3 is 3. Now on the bottom, I also need to distribute. That 3, I'm going to put it right on the 3, and of course it'll be 3 to the 3rd. Okay, so that's not really 3 times 3. It's actually 3 to the 3rd, which is 3 times 3 times 3. We'll get to that in a little while. But we also need to take that 3 and distribute it to the h to the 7th, which gives us h to the 21, because a power to a power you multiply. So that's just rule 3, actually rule 4. It's the same thing. 3 and 4 are the same. You distribute the outside exponent to each and every exponent on the inside, and a power to a power you multiply. So now what else could we do? There's a 2 to the 3rd, and that's 2 times 2 times 2. So the answer is 8. And there's also a 3 to the 3rd, which is 3 times 3, which is 9 times 3, which is 27. And then after that, could you cancel anything right here? No, they're all different variables. So that's as far as you could go. F to the 15, G to the 3, H to the 21. And that's it. That's your answer. You will have to answer this tomorrow on the test all by yourself. Let's check out number 9 here. Number 9. What rule could I apply? And you guys might tell me different rules. I mean, there's many roads to the same place. What do you guys say?
Rule 5.
Rule 5, which is what? Anything to the 0 power. Oh, my favorite rule, yeah. So x to the 0, that's just 1. So I could just scratch it out. Now you're thinking, what do you mean you could just scratch it out? Well, if I did replace x to the 0 with the 1, it would say negative 25 times 1. It would still be negative 25. So I could just scratch it out. What other rule could I do?
You could do
The negative, instead of telling me the numbers, go ahead and say negative 1, right? The negative exponent rule. This guy is going to come down. And not only that, guys, I could also look at the coefficients and imagine if this were just a regular fraction, what would that say right there? What is negative 25 over 5 really? It's negative 5, or negative 5 over 1, right? So that's what I'm going to start my answer with down here. I'm going to put a negative 5. I could put over 1 if I want. The x to the 3rd on the bottom did not move, so I'm going to leave it down there. There is no more x's up on top. And that y to the negative 1, when I move it down, it becomes y to the positive 1. And after that, there's really nothing else to do. That's your answer. However, on the multiple choice portion, they'll probably write that negative sign. This negative sign, they'll probably put it right here in the middle. So your answer will probably be negative fraction 5 x to the 3rd y. They will not write a 1 out here in the front, and they're not going to write the exponent of 1 because it's not necessary. So that's how they would write the answer on the multiple choice portion. Let's try number 10. Number 10 is very interesting. 10 is interesting because, again, when you have parentheses, what do? With an exponent on the outside? Distribute, which means you multiply exponents. Now, is there anything to distribute over here? No. Okay, so this portion doesn't even need the parentheses. As a matter of fact, whenever I see parentheses with no exponent, I like to rewrite it without the parentheses. I'm just going to put a times b squared. That's what I'm going to write right there. Now, on this first part, it's a little trickier because you really need to think this is a negative number. Yeah, it has a and b, but it's a negative term. And when I take a negative term, because the negative is included in the parentheses, when I take a negative number and go to the third power, do I end up with a positive answer or a negative answer? I end up with a negative, right? So it has to be negative. That's what I'm going to start with. I'm going to start by putting a negative sign right there. And then, of course, I'm going to distribute. Okay, so I'll have a A to the 3 and a B to the 3. And now after that, it's just a question of doing rule number 1, the very first rule that we learned. When you are multiplying terms with the same base, add the exponents. So keep in mind, guys, you really are multiplying right here, multiplying there. You're multiplying everywhere. So you could rearrange this how you want. Now, if the negative sign is confusing you, what you could do also is just put a negative 1 times A if you want. So you could call that negative sign a negative 1 times A. That way you could rearrange everything. If you rearrange everything, you have a negative 1 times A to the third times A times B to the third times B squared. Now, some of us at some point are not even going to have to show this work. We'll just be so good at it that we could just add them up in our heads and get the answer. So I know that when I add A to the third times A, when I multiply A to the third times A to the 1, I need to add, and I'll get A to the 4th. When I multiply B to the third times B squared, what do I get? B to the 5th. And last but not least, if I were to multiply negative 1 times this stuff, it'll just make it negative, right? So that's the way my answer is going to look. Negative A to the 4th, B to the 5th. Of course, you could put a 1 right here, but on the multiple choice answers, they will not. They'll just leave it negative A to the 4th, B to the 5th. So, as you can see, they get more challenging. Sure. So let's zoom in on number 11. Let me ask you this. Could I cancel this B up here with this B to the 4th right now? No. Now let me tell you why. It's inside parentheses, right? And you're supposed to do something first before canceling. So let's take a look at the parentheses. There's nothing to do inside the parentheses. On the outside of the parentheses, you really do have a negative exponent. What I'm going to do is I'm going to distribute this negative 3 to the power of 1 right there on the 2, and I will get 2 to the negative 3. And then I distribute it right here, and when you multiply that, you're going to end up with A to the positive 9, because negative 3 times negative 3 is positive 9. And then I'm going to distribute the negative 3 times the 1 on the B, and I'll get B to the negative 3. Are you with me? Okay. On the bottom, I'm just going to rewrite it. 8, A to the 6th, B to the 4th. Now, from here, I need to apply other rules. Now I can cancel things out. So I could do the canceling rule, or I could do the negative exponent rule. Which one do you guys want to do? Canceling or negative exponent? Canceling. Okay, so what would we cancel? What would we cancel right here? Do I cancel out the B's? No. The A's. How many A's do I have on the bottom? How many A's do I have on the top? 9. If I do cancel 6 of them with 6 of them, how many do I have left? 3. Where are they left? On the top. So look, all 6 A's cancel out with 6 of these, and there's going to be 3 left up there. Okay? And there's nothing else to cancel. So I need to go to my last rule that I have not applied yet, which is the negative exponent rule. Anything with the negative exponent has to get moved to the other side of the fraction, and it becomes positive. So this 2 to the negative 3, I need to move that down. This B to the negative 3, I need to move that down. So what I like to do is rewrite what I have so far, and I'm going to start by writing what I don't move. The 8 down here did not move. The A to the 6 on the bottom is no longer there, but I do have a B to the 4th down here that did not move. Up on top, I have what left over? I have the A to the 3rd, okay? And this 2 to the negative 3, I need to move it in front of the 8 that did not move. So the 2 to the negative 3 becomes 2 to the positive 3 right in front of the 8, which means I need to multiply. And then the b to the negative 3 moved down, and you're going to have b to the positive 3 right after the b to the fourth. So b to the positive 3 right after b to the fourth. Are you with me? So far we have this right here. And now let's continue simplifying. Rule 1 says multiply b to the fourth times b to the third. What do I do with the 4 and the 3? Do I multiply them? Add them. Okay, and that is going to give us, instead of b to the fourth times b to the third, that's going to be b to the ninth, right? No, b to the seventh. Add them. Okay, so that's changed to b to the seventh. And then what is 2 to the third? 8. So I really have 8 times this other 8 right there. So let me write my answer. Finally, I have the a to the third up on top all by itself. On the bottom, what do I have? 8 times 8? 64. B to the 7th. That is your final answer, ladies and gentlemen. Number 12. What could I do first on number 12? You could distribute, right? But wouldn't it be nice? I mean, there's a lot of things in here to distribute, right? Wouldn't it be nice to clean it up a bit before we distribute, right? So let's look at the inside of this thing. Let's ask ourselves, could we cancel anything out? Could we move anything? Could we make it look nicer? The answer is yes. Obviously, I can't cancel the 3 and the 2. Those are coefficients that can't be reduced. But the x's, yeah. There's 3 x's up on top. All 3 x's are going to disappear with 3 of the 4. That means that there's only going to be 1 left. So there's no more 4 x's on the bottom. There's only 1. And there's absolutely no x's left up on top. How about the y's? I could cancel out all 3 y's with 3 of the 5, and you're going to have 2 left. That's right. So all these 3 y's are gone. And I only have a y squared left up on top. And then what else could I do on the inside? The z's. Could I cancel out the z's? Can't cancel them, but I have a negative exponent right here, which means I'm going to move it up. And when I move it up, it's going to become times z to the positive 2, right next to the original black z that did not move. So I could scratch this out because I already moved it up and it became positive. Now this is really, really messy. It's really ugly. So to be safe, what I would do is rewrite everything with what I have right now. So inside the parentheses, I have the 3, I have a y to the second power, and what is z times z squared? What is z times z squared? Z3, right? Or let me rephrase that. What is z to the 1 times z to the 2? Z to the 3, right? Okay, so that's a z to the 3 up there. And then on the bottom, let's see what we have left on the bottom. We definitely have this 2 right here. So let's write 2. And then we also have an x to the 1. And honestly, nothing else. Just an x to the 1. But I'm going to write it as just x. I'm not going to actually put to the 1 because it's unnecessary. Now keep in mind, this is all inside the parentheses, and on the outside we still have the power of negative 3. Are you with me? Now at this point, I could distribute the negative 3 to each and every power and multiply them, right? Every single term. Or I could change it to a positive 3, but I could flip the fraction and change it to positive and then distribute. So I either distribute and then flip everything around, or flip and then distribute. Flip and then distribute? And if you want the other way, go for it. But I'm going to flip and then distribute. So on the inside, I'm going to have the 2x up on top. I'm going to have the 3y squared z to the third on the bottom. And that negative 3 up here, since I flipped it already, it's going to become a positive 3. And then I'm going to take this 3 and put it on the 2. So I have 2 to the third up on top. Put the 3 on the x. X to the third up on top. Put the 3 on the 3. That'll be 3 to the third on the bottom. Put the 3 on the y squared, which will become y to the 6 because you multiply exponents. And then put the 3 on the z. That'll be z to the 9th because 3 times 3 is 9. The only other final thing to do is to do the 2 to the 3rd and the 3 to the 3rd. 2 to the 3rd is 8. So you have 8x to the 3rd. 3 to the 3rd is 27. 3 times 3 times 3 is 27. Y to the 6, z to the 9th. It's a lot of work. You're going to have to do it tomorrow. Copy that down, please. So on number 13, we have 33 over 11. Like I've mentioned before, I like to look at the coefficients and pretend that they're a single fraction, single numeric fraction. So I like to think, what is 33 over 11? What do you guys say? 33 over 11. It's 3. Now, where does the 3 belong? On top or bottom? On the top. Because 33 divided by 11, the answer is 3, and 33 is bigger, so the 3 goes up on top. So I really have on my answer so far, I have a 3 up here. Now, how about the r's? Well, I have 3 r's on the bottom. These 3 r's cancel out with 3 of these 7. I will have 4 left up on top, so I'll put r to the 4th up there. And then the s's, the s to the negative 4 needs to be moved up. It'll become s to the positive 4, but I need to multiply with that s to the 3 up there. So what is s to the 3 times s to the 4th? That is s to the 7th. So I'm going to put s to the 7th. There's nothing left on the bottom. I could put a 1, but that would be totally pointless. Final answer is 3 r to the 4th, s to the 7th. That's it. You don't need to divide it by 1, because anything divided by 1 is just that same value. Let's move on. Number 14, the last one on this review. Number 14, I am going to cancel things out. And again, I like to look at the coefficients. If there's a coefficient on top and the bottom, I like to look at that as a regular fraction, numeric fraction. So 6 over 24, could I reduce that? Yes, what is it reduced to? 1 over 4, right? So the 6 and the 24 becomes 1. Let me do it in red. 1 over 4. So that's my new fraction. So on my answer, I could put a 1 up here, a 4 down here. And let's move on to the f's. I have a f to the negative 3, which I need to move. And I have a f to the negative 3, which I need to move. But they're identical. Whether they're positive or negative, they're identical. So what could I do when I have the same identical thing on top and bottom? I could cancel it out. So that's what I'm going to do. Just scratch it out, they're gone. And I could also cancel out the h's. So I have 4 h's on the bottom. These 4 h's cancel out with 4 of these 7, which means I have how many left over on top? H to the 3rd power up on top. Now the last thing I'm going to do is I'm going to take this g to the negative 5, and I need to move it up. So for the sake of being a little neater, let me rewrite everything. I have a 1 on top. I have a g to the 4th up on top. I have the g to the 5th that I moved up that became a positive 5 instead of a negative 5. And I also have a h to the 3rd up there, h to the 3rd. And now I'm just going to do this math right here. G to the 4th times g to the 5th, that is g to the 9th. Add exponents. So your final answer will be g to the 9th, h to the 3rd over 4. You do not need this 1 out here in front. Now you could write it, but on the multiple choice they will not have it. That would be your final answer right there. If you understand all these questions, you should be ready for the test tomorrow. I recommend you practice these types of questions and also practice your practice test that I just handed out in class.